Welcome to this e-learning module from Synapsys Solutions Limited. This training module will focus on the SIP+ multi-protocol. This module will go through the initial setup of the SIP+, how to configure the drivers available, and how to output the data in various ways. The SIP+ has various ports with corresponding LEDs for use with the multiple protocols available. 2 Ethernet ports are available for connection and comms to a configuration PC and for communicating with protocols via TCP/IP. 1 RS485 port to be used for connecting to the Modbus master driver to multiple slaves. 1 RS232 port suitable to connect to a Modbus network, a third-party MBus level converter, or a supervisor port of a trend controller. A 24-volt DC power supply is required to power the SIP+. There are universal I/O ports, a USB port and an HDMI port, which are still currently under development. There is also a CAN bus connection port on the bottom of the SIP+ out to the right side. This is for connection to the SIP serial slice or the SIP MBus level converter. The various network connections for the SIP+ can be seen in the diagram. Slices can be connected to the right side on the DIN rail, adding additional MBus or Modbus networks. The RS485 port connects out of the top, the RS232 out of the bottom of the hardware, and both Ethernet ports on the bottom left of the SIP+. The SIP+ comes in 3 variants, defined by 3 separate product codes: the SIP+ EMT, SIP+ EMT-IF, and the SIP+ data. The SIP+ EMT allows any of the available protocols in the diagram to bring data in and export via an automatic CSV report or via the inbuilt dashboards. The dashboards give visualization to the data. This will be discussed later. The CSV reports can be exported via email, FTP, or FTPS to Synapsys Solutions or any third-party monitoring software, or directly to a recipient. The SIP+ EMT-IF has a very similar scope of use, with the addition of the ability to interface from one protocol to a trend or backnet BMS or an IoT platform using REST or MQTT. The third product is the SIP+ data. This is specifically a data logger device. It allows a larger number of points to be created and store more data in its internal database. However, the SIP+ data only allows this data to be exported via CSV using email, FTP, or FTPS. There are no inbuilt dashboards and there is no interfacing available. All of the available protocols in all SIP+ products can be seen here. The SIP+ utilizes 2 Ethernet ports with individual IP addresses. This allows 2 Ethernet networks to be connected on 2 completely separate IP ranges. By default, only Ethernet port 0 is available with a default IP address. The other can be configured through the web page. To begin configuration, connect a PC to a SIP+ using a Cat5 cable from the PC Ethernet port to the SIP+ Ethernet port 0. Ensure the PC's Ethernet port IP address is set within the range available. It would need to begin 192.168.1. The subnet mask specifies the range of IP address that can communicate with the device. Synapsys Solutions do supply specialist software via SIP integrator called SIP Search. This software will search an IP network that is visible to a PC for any Synapsys Solutions products. Please contact Synapsys Solutions for more info on this. Once a SIP+ is connected, the web pages will be available. Use a web browser, Google Chrome, Mozilla Firefox, or Microsoft Edge, and enter the IP address of the SIP+ into the URL bar at the top of the screen. The default IP address for a SIP+ is 192.168.1.128. This will display a login page. The default login username is admin with a capital A, and the password is password, all lowercase. The first configuration that is required in the SIP+ is the IP config page. The IP addresses will need to be set in accordance with the network the device will connect to. This is also where a second IP address can be set for Ethernet port 1. The global settings page allows a user to set a site name, SIP name, and set time settings as required by the site. There is also a reboot and a ping function available. To start acquiring data, the desired drivers will need to be created and set up. This is done in the Manage Drivers page. All available drivers can be seen on the slide. The Ports drop-down box is used to change the variation of protocol. For example, to use Modbus TCP over IP, select the Modbus driver and select the Ethernet port option. This is also where a SIP slice can be seen and configured. As slices are connected to the SIP+, they will appear in the port drop-down list. The Manage Drivers also allows an alias to be entered for each driver. This makes it easier to organize which driver is which when using more than one of the same protocol. The cog to the far right side of each driver contains the communication settings for that driver. Each will be dependent on the driver and port selected. I will go through each of the COM settings pages as I go through the drivers. The COM settings for the Modbus driver vary depending on the port defined. The baud rate, parity, data bits, and stop bits are only relevant to serial connections of Modbus over RS485, RS232, or using a SIP serial slice. These settings are used to define specifics related to the data as it travels along the serial connection cable. The timeout defines how long the SIP+ will wait after sending a message and not receiving a response before sending another message. The polling period defines how often the SIP+ should attempt to communicate with the Modbus slaves to get data. The two protocol options for Modbus are Standard Modbus or JBus. There is very little difference between these two options. The only noticeable difference is that JBus uses registers that start at 0, whereas Modbus registers start at 1. This means that register 1 using Modbus would be the same as register 0 using JBus. Zero value on comms failure defines what happens to data when a SIP+ fails to get a response from a slave. When a slave is no longer available when this is off, the SIP will hold the last known reading. When it is on, it will set all values from this slave to 0. The communication failure threshold defines the number of messages the SIP+ failed to get a response from before defining a certain slave as a failed device. Once the COM settings have been set up for the meters attached, the slaves and points need to be configured. This is done in the Define Points page. After creating a Modbus driver, this will appear as a new option in the menu. To create a new slave, press the Add button and enter the slave address. When using TCP/IP connection, an IP address is also needed. For each slave, the points that are required from the meter are entered into the table. To create points, add rows to the table using the orange arrow button. The register number is an ID number for the specific parameter that is required. The quantity allows multiple consecutive registers to be configured and polled at once. The data type needs to be defined correctly as per the meter manufacturer guidelines. The function code can be defined as coil, input, holding register, or input register. Function codes 1 and 2 are for binary or digital values of 0 or 1. Functions 3 and 4 are whole number values. The next two slides can be used for reference when determining which data type is required. The following slides will go into more detail on the 4 function codes and what these mean. The scaling factor allows a multiplication to be made to the value after the SIP+ has received it. In Modbus, only whole numbers can be sent, so if a decimal value is required, it would need to be scaled. For example, the value for a temperature sent by a meter might be 215, but the actual temperature for this value would be 21.5. This would require a scaling factor of 0.1. This works both ways. Dynamic scaling can be used when it is required that a value read by the SIP plus will need to be scaled by a second value in another register in that meter. The bit mask allows specific bits from a digital 16-bit register to be defined independently. The comms traffic and the custom comms tools are used for diagnostics. The comms traffic page shows all messages in and out of the SIP plus Modbus driver. Green shows incoming, yellow shows outgoing messages. When performing correctly, these should be alternating as a message and response sequence happens. When all messages are yellow, it means the SIP is sending messages but is getting no response. And when there are red messages, it means there is an error, which will be defined by an error code. The last 100 comms packets shows the messages sent and received in original hexadecimal format. The last 100 feedback messages shows in plain English what is happening and what errors are being flagged, if there are any. The custom comms page allows more specific diagnostics to be done. The read section will allow for individual registers to be read retrieving data. To find a value, enter the details of the slave, the register and the factor and offset. The bottom of the page will display both the request packet sent by the SIP plus and the response packet received from the Modbus slave. Modbus errors will also be displayed if there is a problem with the configuration. A list of error codes and what they mean can be seen on the next two slides. MBus can communicate over serial using the RS-232 or 485 ports, or over TCP/IP using the Ethernet port. A key aspect of MBus is the requirement for a level converter after the MBus master. This can be a third-party level converter or a SIP slice from Synapsys solutions. Configure the port options depending on the type of connection required from the SIP plus to the MBus level converter. As mentioned before, the SIP slice option will become available as slices are connected across the DIN rail to the SIP plus. In the COM settings options for MBus, when using a serial connection, various settings need to be configured as per the meter manufacturer documentation. Polling interval can be set as to poll the meter as often as is required. As MBus meters can be battery powered, slowing down the polling interval can ensure the battery lasts longer. The comms failure settings describe the requirements for when an MBus meter goes offline. Max telegrams and ignore checksum can be used for specific scenarios and refers to the telegram messages being sent from the MBus meter to the SIP plus. Secondary addressing allows for two different ways of addressing MBus meters on a network. Primary address generally requires manually configuring meters to set an address number between 1 and 250. Secondary addressing automatically defines the address as an 8-digit serial number. This will generally be the serial number of the meter, meaning all addresses will be unique. As mentioned, when using an MBus serial connection, an MBus level converter is required. The correct unit load is required for the level converter, ensuring the current is correct across the network. The level converter will sit after the MBus master or SIP plus and before the first slave. On the Define Points page for the MBus driver, the Discovers Meters button will allow the SIP plus to search its visible network for all primary addresses within a range or all secondary addresses. Open the Discover Meters tool and enter a primary address range between 1 and 250, or select a secondary addressing tick box to search the full range of serial numbers available. When the search is completed, all available meters will display on the right side of the pop-up. Use the Read button to learn the points available in the meter. Once all the points are shown, they can be added to the list of points being polled by pressing the Add button. Points can also be added to the table manually by adding a slave address at the top of the page and adding rows with point IDs into the table. There is also a duplicate function if multiple meters of the same type are used in the same network. The trend client and the trend driver differ depending on the SIP plus variant. When using a SIP plus EMT or the EMTIF, the trend driver can be used. With the SIP+ data, the trend client is available. In this module, we will focus on the trend driver. Add the trend driver in the Manage Drivers page and select the port required. There are two port options available, Ethernet and Serial 1. The serial connection allows connection directly from the RS-232 port of the SIP+ to the supervisor port on an IQ controller. This can be any trend controller, but more information will be required for connection to an IQ2. This is where the data flow option will become relevant. With Ethernet selected, there are two secondary options available for connection using TCP/IP. In the COM settings window, select Ethernet to connect directly to the VCNC of a trend controller using the IP address and port number available, or define a VIC driver and select the VIC option from the drop-down list. More information on the VIC driver will be later in the module. When a connection is made to the trend network, any points on that trend network are available to be polled by the SIP+. To define the points to be used, define the LAN and outstation where the points are located, define the module types and the module numbers. The modules define the individual points to be picked up. To find information on the points available, connection to the trend network by a trend engineer is required. The BACnet driver can be used to obtain data from a BACnet BMS, pulling points from multiple devices. This protocol can be configured to communicate over serial or Ethernet over IP. To communicate over a serial connection, a separate BACnet MSTP driver must be configured using the RS-485 port. The SIP+ acts as a separate device on the BACnet network as a router or gateway. The BACnet client device, as well as the BACnet servers that will be looked at later, sit as virtual BACnet devices on a virtual BACnet network. The BACnet client sits behind the router using a unique network number. BACnet uses a structure as displayed on the slide. All devices will need to be on the same BACnet port to communicate. Most devices will sit on network number 0, or the local network. Any devices behind a BACnet router of some kind will sit on a unique network number, including the SIP+. All BACnet devices and objects must be identified by an instance number, which will be unique through each level of the hierarchy. The properties of BACnet objects include a present value. This is the property that we use to poll data. Once the BACnet router has been configured, the client device can be created in the Define Points page. Open the BACnet Client tab at the top left of the page and add a new client using the Add Device button. The new device needs a unique instance number and label. There is also the optional settings to give a description and location to the device. This will make it easier to identify on a network of other devices. Adding the BACnet client will open the ability to create new points in the table. The BACnet Map tool will also be made available. The map will enable a full search of the visible BACnet network, showing all devices and points available to be polled by the SIP+. To discover devices, highlight the site by clicking the label and press the refresh button. The Map Info tab can be used to show the status of the search. When all devices have been mapped, highlight the device required to learn the points available. Points will be displayed as groups of object types. Valid object types to the SIP+ are analog input, output and value, binary input, output and value, multi-state input, output and value, and accumulators. Refresh the object type header to learn the labels of the points and other information, including the present value. Once the correct points have been found, highlight them and drag and drop them into the table to add them to the list of points to be polled. Points can also be mapped manually using the arrow on the table and entering information in manually. In the bottom right corner of the page is a copy and paste button. This can be used to copy out all selected points in a CSV format. These can then be pasted into an Excel document to edit or create new points. Copy the whole table in Excel and paste back into the SIP+ using the paste feature. The first IoT protocol to be added to the SIP+ was MQTT. This is a lightweight protocol communicating using an Ethernet connection over TCP/IP. This can be used with a local MQTT broker or IoT edge device, or a cloud-based broker. Use the COM settings when in the Manage Drivers page to configure the connection settings to the desired MQTT broker. More information about MQTT brokers can be found online or through Synapsys solutions. However, this is not a feature we supply currently. MQTT requires a broker as a central hub for communications. This works as a server device, accepting connections from and passing data between MQTT clients, like the SIP+. The SIP+ can act as both a publisher or a subscriber device in the diagram provided, meaning it could send data to an MQTT broker, or it could receive data back. Examples of brokers are Amazon Web Services, Google IoT Cloud, and Microsoft Azure. After setting up a connection to an MQTT broker, the points can be defined in a Define Points page. The address of the points in MQTT are named topics. This is what is used by the broker to decide where data is coming from or going to. Clients subscribe to a topic to receive data on a change of value basis. The COV setting allows how much a value must change by to send or receive an updated value. The property settings change the way the data will be sent or can be read. The SIP+ either uses plain text numerical values or JSON formatted data with the timestamp. The access option defines whether the point is read-only, which means the data is being sent from the broker to the SIP+ only, write-only, where data is coming from another protocol and being sent to the broker, or bidirectional. The SIP+ eMTIF provides the ability to interface data from one protocol to another. Once data has been brought into the SIP+, it can be made available to a trend or BACnet BMS or out over an IoT protocol. To configure the protocols to export data, create one of the server drivers in the Manage Drivers page. This could be a VIC to communicate over a trend, BACnet over IP, MQTT, or REST server. To interface to a trend network, create a VIC driver. The VIC driver allows up to 100 outstations to be created as unique trend devices on the network. Use the COM settings to define the node and port information of the two onboard VCNCs, the UDP group and the LAN number. The human GUID can be entered here as per the site requirements. When configuring the VIC driver, ensure the UDP group is set the same as the devices that the SIP+ will be communicating with. All LAN addresses on that UDP group must be unique. Use the VIC Define Points page to create up to 100 outstations, using the column down the left side of the page. Add a unique outstation number between 1 and 119, ensuring that 2, 3, and 10 are not used, and press the Add button. The new outstation will appear and can be configured. Open the outstation and add a label, alarm, specifications, and attributes that may be required. The next 4 headings will enable individual configuration of sensors, knobs, inputs, and switches. The final option defines the users for the outstation, allowing trend security to be added. When configuring the required modules, ensure labels, units, high and low limits, and plot information is entered where they are needed. The copy and paste function allows this information to be copied out in a CSV format and edited in an Excel document. The table can then be pasted back into any other created outstation. You can also right-click an outstation to duplicate it. To interface data to a BACnet network, a BACnet driver over IP must be created in the Manage Drivers page. This is the same driver needed to create the BACnet client, as discussed earlier. In the Define Points page, the BACnet server page should open by default. As with the client, server devices need to be added. Use the Add button at the top of the page to add a new server device, giving it a unique instance number and label. Again, the description and location are additional extras. To create data points in the BACnet server, use the table on the left of the page and press the orange arrow to create points. Each point will have a unique instance number, object type, and label. For each object type, different configuration settings will show in the main body of the page. These settings are used to configure the properties of the individual points. For more information about the configuration of these settings, refer to the SIP+ technical guide or contact Synapsys Solutions. To interface to an IoT protocol, there are two options available, MQTT or REST. When using MQTT, configure the driver as described previously in the module. Ensure where points are created, they are set to either write-only or read-write. Interfacing between two protocols requires the points to be linked together. This is done in the Link Points page. Select the two drivers to be linked from the drop-down boxes at the top of the page. Select the points required on both sides and press the link button. These points will be linked in the order that they are selected. Make sure the links are saved using the button on the bottom right of the page. To select multiple points at once, the Shift button can be used. Hold Shift and select 2 points to select all in that range. Another shortcut will allow all points to be linked in one go. Ensure no points are selected and press the Link button to link all points in the order that they are currently in.